Tech. If you haven't watched this show before, this is a show where we get to talk about all the latest and greatest launches. And today we're live from reInvent in Las Vegas, getting ready to talk about some of the amazing launches that happened over the last couple of days here at reInvent. My name is Nathan. I'm joined by my co-host here.
Hey everyone, my name is Jeff Marushak. I'm a senior solutions architect on our DoD Air Force team. This is my second reInvent. I'm excited to be here on stage with you guys, and really excited to talk and learn a little bit more about Lambda and what's new with Lambda. So our guest, Chris, why don't you introduce yourself?
Sure. Hi, my name is Chris Greenwood. I'm a principal engineer with AWS Lambda. This is my sixth reInvent and second with the Lambda team.
Wow,
Yeah.
cool.
Wow. So I understand Lambda has some exciting launches.
Yep.
Give us the elevator pitch for what just launched and why we should be excited about it.
Sure. So what we launched, which was yesterday in Peter DeSantis' Monday Night Live, was Lambda SnapStart, specifically for Java functions at launch. So SnapStart is primarily targeted at the cold starts of a Lambda function. So traditionally, when a Lambda function runs, it kind of has two operating modes. It either has an instance of the function that is already running for that function that can serve the invoke, or we need to spin up a new execution environment for the function, and that can traditionally take a long time, at least a long time relative to your normal invoke time. That makes Lambda challenging for customers that have applications with low latency requirements.
Yeah, I remember talking to some customers before that were trying to keep a Lambda function warmed up by hitting it constantly with requests. But even then, what if they have a sudden spike in traffic and the number of Lambdas has to increase? They're still going to hit a cold start. So
that's right.
They had a challenge there.
Yeah, and so customers will often use something like provision concurrency with Lambda to keep a certain number of function execution environments alive all the time. But as you say, if they have to spill up over the number of provisioned instances that they have, then you hit cold starts. And then even if you don't, that's paying for a set of function execution environments all the time, even if you're not using them. So it is more expensive than it could be when you're at low load, and it is not really solving the cold start problem under high load. And so SnapStart is a mechanism not for reducing the probability of that active scaling up, but it is really for reducing the latency with which we can scale up into a new execution environment. And so what we do is, traditionally, when an execution environment is created, it starts up, and we have to start the language runtime. We have to initialize customer code, which does things like class loading. It does things like static function initialization, things of that nature. We let all of that happen when the function is updated and when a new version is published, not on the path of an invoke. And then after that happens, we take a VM snapshot of that execution environment. And then when you actually have to scale up, when an invoke comes in, or when you need a new execution environment, we're able to restore a new execution environment from the existing snapshot. So we've basically cached all of that latent time-intensive work of readying your execution environment for an invoke. We've cached that, and we're essentially reusing that over multiple VMs.
So let me make sure I understand how this is working properly. So traditionally, if I wanted to scale from 0 Lambda function instances to, let's say, 1,000 Lambda function instances, there would have to be 1,000 different cold starts where it would be loading up all this code. With this new technique, it's going to do that once at the time that I upload the function code the first time, and create that Lambda function version, and then it's going to be able to take that preloaded sort of template and scale that out across 1,000 different function instances based on that initial pattern.
That's right. Yeah, a slight correction to that is that we actually take more than one snapshot when you create a function version. Okay. So we do that for primarily for resiliency purposes, so that you don't have one snapshot that if something were to happen to that snapshot, then all of your subsequent scale-ups are impacted. So we take multiple snapshots for each function version, but it is on single digit. So say 5 to 10 snapshots for a function version. And then when you go and create those 1,000 execution environments, because you got 1,000 invokes all like right in a row, we're able to reuse those 5 to 10 snapshots over those 1,000 execution environments.
That's amazing.
Yeah, so can you talk about how this works between regions, between availability zones? Is it a snapshot per availability zone, or is it all within a region?
So it's all within a region. As I was saying, we take multiple snapshots for each function version, specifically to guard against things like AZ failure, guard against things
gotcha.
like software bugs that are latent in the snapshot.
Yeah, okay.
And so we have caching infrastructure and we have storage infrastructure that is specific to availability zones, and we protect against that. But the snapshots themselves should be thought of as essentially just regional snapshots of the function.
Well, I bet you there's a ton of customers that are really happy about this, because whenever you talk about Lambda, inevitably cold starts come up. And so this is there to make a lot of people happy. And I imagine this opens up Lambdas to some more application types. Do you have any ideas of what this is really going to open the door for?
Yeah, so Lambda historically has been really good for things like event-driven architectures, things like streaming workloads, things like data processing. These things that are sort of batch-based, that are data-based, often are a little bit more sort of throughput-oriented than latency-oriented.
So it's not necessarily real-time response. It's something that kicks off in the background.
That's right. So if I were to say, hey, on every time I upload a JPEG image, I want to create a thumbnail
That's
of that
my
image.
favorite.
Yeah.
I always use that one.
Yeah, this is the one that everyone uses.
Yeah.
So if you were to say, upload a JPEG and say, I'm going to create a thumbnail of that JPEG, the fact that you've got a 5-second cold start isn't really significantly going to impact the experience of that function. But if you are, say, refreshing a web page, a responsive sort of responsive web API, things of that nature, we think this is really going to open Lambda up. Customers are doing that on Lambda already, but we think it's really going to open Lambda up to those use cases to a larger degree.
So I'm thinking frameworks like Spring, perhaps. If I'm running my Spring application in Java, now I can put that into a Lambda function.
Yeah, and so one of the primary reasons we started with Java for SnapStart is really around which languages feel the cold start experience the most, or the most acutely. With Java, big dependency injection frameworks like Spring Boot, like struts, are pretty common. They make writing code and writing a function and writing a web service really easy. But these frameworks were often built for applications where the JVM is bounced once a month when you deploy your code, or once a week when you refresh your instances. And so in that context, 10 to 20 seconds of a cold start just isn't all that impactful. And so for decent reason, those frameworks haven't thought a ton about Lambda cold starts. And so Java probably feels the most acute pain of cold starts today, which is why we targeted Java with the initial release.
Okay, so you say acute pain. This is going to be pain relief. I understand you have a demo, and you're going to show us just how much of a pain relief this is.
Yeah. So what we're looking at here is a function. It uses the Spring Boot framework. So it's a Java function, and really all it's doing is it's serving content out of memory. So it does little more than just accept the request, compute some static data in the function, and return using the Spring Boot framework. We're going to go to our CloudWatch dashboard here. And what we're looking at here on the left is, oops, my Zoom is not behaving here. What we're looking at on the left is init counts is the line bouncing up at the top. And what that means is that's your traditional cold start. So every time a new execution environment is brought into the application, a log is emitted with an init record, and it tells you how long that record that init takes. And then on the right, we're looking at all-up latency. So I'm using a function URL, which is a feature that was announced about a little less than a year ago, to get the all-up latency of the Lambda function. So to look at the all-up latency of the Lambda function, you have to include the init time. But if you look at Lambda's duration metric, all you're seeing is build duration, which for the Java runtime does not include the init time. So what I'm looking at here is I'm looking at the function URL latency that includes all up. It includes all of the non-instance time and the time spent in the execution environment executing the function. And so we're looking at 3 percentiles here. We're looking at P50, P99, and P99.9. And you can see that P50 is super low. It's down in the, what do I want to, I'm looking at, it's down in the range of 10 to 20 milliseconds. And then your P99 and your P99.9, 5 to 6 seconds. So that's a pretty significant delta between your warm starts, which are at the P50, and your cold starts. So what I can do with this function is I can go down and I'm looking at SnapStart here. It says SnapStart is none, which means that the feature is disabled.
Right.
I can modify the function to say on published versions. And so saving that does nothing yet. What that does is it says, when I publish a new version, I'm going to have SnapStart enabled on that version.
So it's not going to take snapshots and enable snapshot on previously published versions.
Correct.
All in the future versions.
Correct.
Gotcha.
And for a customer using the unqualified invoke or using the latest alias, they're going to have to move either to an alias or to a published version to adopt the feature.
Okay.
So no snapshots have been created yet. I can go. I'm already using the latest. I've called it the latest alias creatively, and I have version 1. I can publish a new version, and so now I'm seeing up at the top here. It's saying that it's creating version 2, and it says that SnapStart adds a few minutes to the version creation process. So what's happening right now is that we're going and we're creating multiple snapshots. We're creating multiple execution environments, downloading the code, initializing the code, and getting those snapshots ready to serve the invokes that are going to come on this published version. Because this is going to take a little bit of time, we're going to switch over to a function that I was playing with earlier this morning.
All right.
So this is a function that is the exact same function, and back here a few hours ago, I switched on SnapStart, and I published a new version, and I flipped my live alias over to the new function version. So on the left, what we're looking at is instead of inits, we're now getting restores. So now in the invoke log, instead of seeing init duration when we are taking creating a new execution environment, we are seeing a restore duration. So I've taken all the init time, I've completely wiped it out, that doesn't exist anymore, and I've replaced it with a new phase, which is called the restore phase. This is basically the act of getting the nominal bits of that snapshot onto the host and into the VM such that the VM can start up. And then the rest
how long does that restore normally take? Does it depend, I imagine, on maybe the memory size of the Lambda or something along those lines?
Yeah, so the restore is constant-ish. It's normally down in the range of 200 to 300 milliseconds before, at which point we can start the invoke. And then from that point forward, we can on-demand load the rest of the snapshot as your function executes. And so depending on what your function does, depending on what dependencies it takes in that process, we can load a variable amount of the snapshot, only loading the pieces that you need.
Wow.
And you can see the results on the right, where at the time where I enabled SnapStart and I created the new function version and I flipped the alias, you see a significant reduction in both P99 and P99.9. And you also see that there's more consistency in both of those. And so this is really highlighting the effects of the SnapStart product. Basically taking what used to be a super, super significant difference between your scale-up path and your pre-scaled path and drastically reducing the delta between those.
So I saw a question scroll by earlier, but is there any cost to capturing these snapshots? Like, do I have to pay for that time where it's capturing the snapshot and storing it?
So when we publish a version, we are going to go and create those snapshots on your behalf. You do pay for just the normal invoke time or it's not invoke time, I guess, it's initialization time at the normal Lambda rate that is involved in creating those snapshots. You don't pay for the storage of the snapshots, you don't pay for the caching of the snapshots, and you don't pay any additional on the invoke path for kind of using the service. But the creation of those snapshots is charged at the Lambda normal rate.
And it sounds to me like the restore, because it takes less time than a normal init, you're not going to be paying for like that init phase that you would normally be paying for.
That's right, yeah. And especially for cases where you have extremely large cold starts, you are paying a significant amount of the execution environment time for the initialization process.
Right.
And you're paying that on every single execution environment that we spin up on your behalf. Whereas in this case, every time you publish a new function version, we're going to take 5 to 10 snapshot versions, 5 to 10 snapshots. We're going to charge you for those once, and then we can reuse those without incurring that cost on every scale-up activity.
That's amazing. We're taking what was a constant recurring charge and turning it into a one-time charge
That's right.
that can
That's
be
right.
reused.
Yeah.
So that's amazing.
You talked about a tip for a customer to maybe move away from using the latest alias. Is there anything else that customers need to know when they go to start using SnapStart?
Yeah, I think that the one thing that we want customers to be aware of is this concept of snapshot resiliency. And so Peter talks about this in the keynote yesterday, and so he gives a good overview of this. But when you're creating multiple execution environments from scratch, there are certain significant materials in those execution environments that are pretty important for correctness. So one example that Peter talks about and that we're going to focus on here is about seeds for random number generators. These are often significant for things like SSL encryption.
Yep.
If those seeds were to be the same, you would then be generating the same set of random numbers, which then breaks some assumptions in software.
You would have 1,000 functions, and they would always generate the same number because
Or
they were
be
coming
based
off
on
the same snapshot.
Yeah, and so with SnapStart, since we're taking snapshots and then we're reusing them across multiple execution environments, if some of those important materials are in the snapshot and are reused in each execution environment, that could be problematic for things like load balancing, for things like generating unique IDs, things like random number generation, et cetera. So the work that we've done in the Java ecosystem has been aided by open source and powered by open source, has been to offer restore hooks into your code that allow your code to be notified both when it's about to be snapshotted and when it's about to be restored, so that your code can refresh these sorts of materials.
So this sounds like a very important deep topic that we don't have time to go into complete detail, but I understand there's going to be a session later for folks at reInvent to attend.
So
I'm assuming you go more into that.
So my session, SVS 404, is later tonight in the MGM, and it's tomorrow morning. We're doing a replay of it. That is not going to talk about snapshot resiliency specifically, but in that one, Julian Wood and I are going to basically do a deep dive on the Lambda architecture, and we're going to talk about some of the snapshot creation, some of the snapshot caching work that really led to the SnapStart launch.
Awesome. Fantastic. And so folks can go get started with this right now on the dashboard. Is there any other places that we should drop into the chat, perhaps, for links to try it out?
Console, APIs, CloudFormation, SAM, all of your kind of familiar tooling should be updated. You're going to need to update your local SAM binary to get the latest. But yeah, all of your kind of traditional tooling should be updated.
Fantastic. Well, I can't wait to see what people build with this and see them getting that cost savings, that faster, lower latency, and great job on this launch.
Yeah, I appreciate it. Yeah, and thanks for having us.
Thank you very much.
Yeah.
All right, everyone, we'll be right back momentarily for our next segment.